the different types of random variables that we have. So we have two different kind of random variable. One is discrete random variables, another one is continuous random variables. Right? In discrete random variables, you have assigned the variable certain discrete values. So x would be some number which you can, these values which you can count. So that is why it is discrete, and there is in between some gap here. Suppose you are talking about person, so a person cannot be half, right, or 1.5 or 3/4. So we have either 1 person or 2 person or 3 person or 4 person or like this. So whenever you are counting, that means you are talking about discrete random variable. Whereas whenever you are talking about continuous, so that means for x we have all the values which are lying very close to each other. So here in this case we can say there are infinite number of observations here like this. So you cannot basically count all these. So you cannot count the observations here. For example, in this case, I would say calculate the length of, calculate the height of each person. So in this case, the height, it could be 5.1, right, inches, or it could be 6.2, or it could be 4.444. So it could be anything, any number in between. So that is a continuous random variable, right? So that is the difference. So based on these two kind of continuous and random variables, we can have different kind of probability distributions also. So let me define that. So we have different kind of probability distributions also. So in the first case, we can write this to be the discrete probability distribution. And in the second case, we have the continuous probability distribution. So here in the discrete probability distribution, you have the random variable x, which is discrete in nature, and here the random variable itself is continuous in nature. So graphically, if you look at these two, so in the first case your graph would something be like this. So the probability distribution, it basically is represented by some function f of x, or you can define this to be p of the value capital X less than equal to some x quantity. So this is the probability distribution. Here the variable x, that is discrete in nature, and in this case the variable x, that is continuous in nature. Now this x could be anything, right, and this represents your random variable. So in this case, the probability distribution, it says that in the discrete case it would have some value like this, here, 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 or here. So this would be the value, because we are now having discrete values at different points, the values which you can count. So all of these values here, they would be positive, and moreover if you add all the values, their sum would be equal to 1. Why? Because we are talking about probability distribution. So here all of this p of x, they are greater than equal to 0, because you know the value of probability is always greater than equal to 0. Another thing, when you add up all these p I x, suppose we are talking about this. So we have p1x plus p2x plus p3x plus p4x. So you would have the answer equal to 1 because the sum of all probabilities is always equal to 1. So this is for the discrete case. For the continuous case, your graph would look something like this. So here your function would something be like this. So it would be some continuous thing, right? So whatever is the area behind this function, that is all going to be the sum of all the probability distribution. So in this case, the probability distribution again is positive. That means all the values here will lie above 0, right? This represents p of x, this represents x, and here also in this case the sum, because this is continuous in nature, the sum is represented by integration. So p of x dx, this is the sum of all the over whole of the interval from minus infinity to infinity. It is going to be 1 always. So this is the condition for continuous distribution. So the basic distributions that we have for discrete and continuous, for discrete variables, we have we have first is binomial distribution, and we have Poisson distribution. And for the continuous case, we have the normal distributions. There are also many other distributions, but the very popular ones and which are mainly applicable in various applications, they are normal distributions. So the question remains as such. So our question was, why are we actually studying these distributions? What is the advantage? So the answer here is, the answer to this question is that in real life phenomena, in real life world, so what do we have? We have various situations which are random in nature. So that means in order to make predictions, about the future events, in order to make predictions about the future events, we use the mathematical models. So these probability distributions are nothing but mathematical models. So basically you have different models, each having the different advantages and which could be applicable onto different applications, so which has limitations and the advantages of their own. So first of all, it has its own properties. Another one would be consisting some different properties and characteristics and could be applicable to different applications, so on. So we have these different kind of and so on. So right, so we have different kinds of distributions. So actually you are the judge here. So you are the judge here. How? First of all, you will decide what you wanted to predict. Then based on that objective, so based on that, you will check your conditions. By conditions, I mean the environmental conditions, what a kind of variables are associated with those conditions, and things like that. So based on those conditions, you will go into the library of distributions. Go into the library of distributions, and then you can look around for the distribution which suits you best. So you will check out the conditions which is available for discrete or continuous case, or there are many conditions other than these also. So you could go and check for all that, and then you can select that distribution, so that you can apply that distribution onto your problem, and using the previous data you could now predict the future outcomes. So after selection, you could utilize that distribution onto your problem and predict that you wanted to. So that is the funda here.